Okay, switch to English. Thank you for coming. Thank you for watching. Today, the sixth lecture in our Smart City series of lectures, we'll talk about ways we as people or companies, organizations can earn money, earn value by sharing. And it's even more for smart cities to be able to come into existence. This concept of economic feedback is vital, and we'll discuss this topic, why that is. But first, let's recapture some of the things we've discussed in the previous 5 lectures, just so we remember. We discussed the concept of smart in smart city. What does smart mean? Some would say smart means stupid, but what it means is connected. Anything connected, we like to think is smart because it can help us with common tasks that we have to do manually today. So we can automate things. And we discussed transport and traffic and parking, utilities, and any type of government organization, healthcare and schools and libraries and waste management and so on. What we don't want is for a smart city to help automate its citizens. So this is what happens in some parts of the world. We don't want that. We want the citizens to automate the city, not the other way around. So we discussed extensively how to avoid building a smart city that intrudes on the rights and freedoms of all its citizens. We discussed privacy at length. We discussed the problems of openness. Having an open infrastructure invites attacks, invites malicious use of the infrastructure. How do we build an open and secure system, a smart city? We discussed harmonization. There are so many technologies. How can we make them interoperate and work together? And last time we discussed cryptography, the basics, the fundamentals, the different types of algorithms that exist, why we use them, what are the benefits, strength, and so on. And this entire series is dedicated at presenting a vision of what a smart city can be. What could be a definition of a smart city? So it's not only connected, but we want to have a ubiquitous access, and ubiquitous means here that it's everywhere, you can say. Ubiquitous access to interoperable sensors and things. We want ubiquitous access to data, information especially from our authorities. We all as citizens pay for the government, and so we also expect access to information. Now, interoperable and open access doesn't mean necessarily free. Okay, and we'll talk more about that, how we can create infrastructures that allow us to not only share costs but also earn money from developing the smart city. We want to have access to smart services in all niches of society. This means localization rather than globalization. We want to have a definition of ownership of information. Any type of information should be able to have an owner, and we need an infrastructure that protects ownership. Obviously, with this also protection of privacy, not only in words, but by design and by default. It is encrusted into the infrastructure. And what we will talk about today is it needs an open market for access of things and data. So open markets make sure that we have a prosperous development of the smart city. We introduced 2 lectures ago the IoT harmonization effort. within IEEE. And we discussed then more detailed all the different types of services available in this proposed infrastructure to help build an open and secure and interoperable smart society. And it includes 4 services that we will discuss today that will allow these open markets to be formed. And these are the formation of digital legal identities, smart contracts, automated provisioning, which means we need obviously the smart society to be able to configure itself without millions of people doing this by hand, and economic feedback. So we get paid for good ideas that help others. So let's talk a bit about incentives. We discussed in earlier lectures this dilemma. Why hasn't the Internet of Things, why hasn't the smart city developed as originally thought? Almost everyone agreed that there would be a veritable explosion of connected devices. And even though we have seen a development, we have seen deployment, it hasn't been even close to half of the projections that were originally made. And the reason, there are several reasons, but one of the more important is this dilemma. So if you invest a lot in infrastructure, what reasons do you have for others to use your infrastructure that you've paid for? So the original idea, obviously, and also the idea with the smart city is that you can interconnect and interoperate. Why doesn't that happen? Well, what reasons do you have for allowing, if you spend 100 million of some unit in infrastructure, why would you allow others access? So if others would access your things, of course, you would create vulnerabilities. How do you restrict it to only those that you want to have access? You would degrade your own performance, because as others use your infrastructure, it puts a load on it. And no system has infinite performance. And what's worse, competitors could use your infrastructure against you. They could create a service that is cheaper because they don't have to invest in the infrastructure, and launch a service that is competing with yours at your expense. And so there is obviously something missing here, and this is also why companies often seal off their solutions. They create their closed silos, closed safe spaces, you could say, where only their application can communicate with their devices. So you have this protectionism everywhere. And now there are many reasons why companies want to protect their infrastructure. One of them is obviously they want to have control over their customers. So they don't want competitors to have access to their customers. They have their developed business model. Creating a business model is not easy. So they have something that works. They don't want to change it. So they want to protect it. And they have a certain influence in society. They have their domain of influence, and they don't want to disturb that either. So by allowing others to enter into your technological sphere also allows competitors into all these other spheres. What companies don't think about is that by opening up, you also get access to your competitors' spheres. So it's obviously a two-way road here. But as long as society doesn't change, as long as the paradigm is intact, doing what you've always done is the safest bet. So it's the lowest risk, and so you do what you're familiar with, you feel safe, and you protect status quo. So this is a big problem for development of the smart city we envision. Now, what are the risks of not opening up? So we talked, it's very evident what the risks are for opening up to many, even though if those risks might not be as bad as you think. What are the risks for not opening up, for playing the protectionism card? Well, if you as private persons want to buy something, you invest a certain amount of money, and you have two options. You have an option between an open solutions that allow you to do other things, or a closed proprietary solution. If all other parameters are the same, which one would you buy? So most would say an open solution. And this is also often what is, if we look in history on different competing ideas, openness standards has won out in most cases. You really need to have an exceptional alternative in order to be able to compete in the long run with openness. And so this is the risk. By not accepting these things that are inevitable, you are at risk of not being able to change in time. There are other factors why companies don't create open and interoperable solutions. So when you create a smart system, within quotes, or connected systems, there are many parties involved. You have manufacturers of devices, obviously. You have those that publish or make the service available. You have the service providers. And in the middle, you have different kinds of operators. Now, operators have a key role in the development of connected services. Often manufacturers or service providers, they don't have sufficient knowledge of how to do everything. So many rely on operators, and we have to ask ourselves, we rely on operators, we believe what they are saying, but are their interests really our interests as manufacturers? So we have, for instance, cloud providers. What is the interest of a cloud provider? Is it to give you, as a manufacturer, the most options you might have? Or is it to make sure that you enter their cloud and never leave? So when we create smart societies and solutions for smart society, we need to take this into account. We need a solution that is good for all, including operator, including manufacturer, including service provider, including publisher. All the reason why any of these become protectionistic is because they're afraid they will lose their domination of their domain, their market, their customers. So we have to take all these actors into account. Now, going to any solution provider, they will say, we're open, we're open, we're open, we have an API. I'm sure most of you have said those words also. So I know I have. So there's a difference between openness and openness. You can have a small door with the door just a little bit open, or you can have a big gate which is wide open. Now, openness, obviously, the most open type of interface you might have is one that is based on open standards. We discussed a bit about the difference between proprietary or bespoke open APIs and standards. So if you have two companies who want to interoperate, well, there might not be a big problem with proprietary or bespoke APIs. Actually, it is even simpler. It's easier to do bespoke proprietary solutions if you are the only one working with it, because you don't have to adapt to anyone. But as soon as you have 3 or more actors who has to interoperate, open standard is the only practical choice, because the number of combinations of interaction as the number of parties grows potentially, while if you use an open standard, it only grows linearly with the number of actors. So open standards, adherence to open standards is for a smart city the only practical option. And this we have reiterated in most of our lectures, is also the basis for the IoT harmonization effort. Now, how does it help companies earn money? How does it help companies open up in a way that doesn't make them lose and allow their competitors to earn everything? Well, first, obviously, it helps with this, openness and security, and it defines ownership. So it's friendly towards the customers of the company, and that's also good for the company. It removes a lot of the work a manufacturer or service provider has to do to configure system, because it's all done by owners who have the true interest. It helps with discovery, we talked about it, but today we focus on it has a model that gives you a natural return on investment on implemented or installed infrastructure. It's based on access and usage. And this should be very interesting to companies, because no longer do they have to worry about possible gains. They have an actual physical method to which they can observe and estimate gains on. Now, it's the last item in the list of what's required in the smart city, and it's actually the knot that ties everything together. This economic feedback model that will be presented here is what can make a smart society truly smart. It's not the connectivity in itself, but the possibility to have open markets on it. This will drive the smart society. So it will provide incentives. If you spend money on a device for your purposes, why not allow others to use it also if it pays for the device? If you get paid for it, why would you keep it private unless it's very sensitive information? Now, users of the same device share the cost, and the individual or company that invest in the device also can stand to gain if there are many users who are interested in the device. So it provides a better use of resources. Instead of forcing each one who wants to do a particular type of service to invest in the same kind of device on the same location for the same purpose, they can share the costs, and for the same amount of resources we can have more devices, and the same we can have more services. This is what's driving the development. For the same amount of resources we get more back. Obviously it promotes interoperability, and instead of competition, destructive competition, we might have constructive cooperation, especially with things that are shared. So we could have competition on what matters, which is the true goal of a company, rather than competition on things that for the company doesn't matter, like perhaps infrastructure. And this we will also see new types of competition, and obviously as competition goes, this will lower prices and increase quality. So it's also good for us as citizens in these smart societies. Another thing that the IoT harmonization does, which is good for the company, is that it allows a company to focus more horizontally. Instead of having a very narrow vertical view of their product or service or offering, they can have a much more holistic, horizontal, broader aspect and offering, and therefore also have more opportunities. So in this image, the same amount of pixels represents the vertical and the horizontal. So if a service provider doesn't have to worry about infrastructure or devices or publish, but just worry about the actual service, the service provider would be able to do a much better service that could be used in a much broader sense. The same with the device manufacturer on the other end. Instead of having to worry about how to publish data and build global infrastructure and create services, they can focus on the actual devices, which would then become more useful. And the operator also. Today's operators could broaden their scope and create better offerings. And as the same as a publisher, as a new type of role where it becomes economically viable to just publish information or buy a device and just publish access to the device. You don't have to create a service. You don't have to create a device. You can just make sure others can use it by publishing access to something, and that becomes a viable business model in itself. So to summarize some of the incentives of opening up in an open market, we create new markets and we have broader markets with more opportunities. With the same amount of resources, we can do much more. We can do things quicker. We can turn things that are typically seen as costs into investments that have a return on investment. We can, as we start to cooperate between companies that normally don't work together, we will see cross-domain solutions. We call this cross-domain fertilization. Companies that don't normally cooperate, you could say like security and healthcare or home automation, these companies, they don't have perhaps a common business model, but as soon as they open up, new actors will tie domains together that were earlier not tied together, and we will see new types of solutions that will benefit not only the original companies but also inventive new ones. We will see a localization that will be able to adapt to each society uniquely. We will have simpler integration. Today, integration projects might be very large and complicated. With an open infrastructure, it will be quick. And of course, reduce development times. That's something that management always likes to hear. So these are the incentives now. How can we do this? We've talked about communicating sensor data. We talked about operating actuators. But now let's talk about money. Now, money, as you know, is a sensitive topic. Anything that is worth anything attracts not only opportunities but also dishonesty and crime. So we have discussed privacy. When we discussed privacy, we compared the difference between anonymity and strong identities, which we called pseudonyms. And we discussed the difference. There are those that favor one approach over the other for one use case or the other. But when we talk about anonymity, pseudonyms is no longer sufficient. So we'll discuss this with legal identities. Anonymity is proposed as a solution in a surveillance state. And there are legitimate use cases where anonymity is required. If we see something that is wrong in a company, in the society, we need to be able to vent that. And the only way to vent that without being able or being the victim of reproach is through anonymity. So there are valid use cases for anonymity, for whistleblowers or for dissidents. But anonymity obviously is also used by criminals and terrorists, or anyone who doesn't want to take responsibility for something. So it makes security decisions difficult, and it makes it easy with the personal data leaks, or easier. And so if you don't know with whom you speak, you cannot make good security decisions. And that was the case for introducing strong identities as a way to protect privacy. If we have strong identities that at least we know who these identities belong to, perhaps not the authorities, but we know, we can trust these identities and we can use it to base our own security decisions on. So we can protect the owner or the information we have as owners, and we can do selective responses. And we discussed the possibility to use these strong identities for surveillance, and this is a risk. And so the method to avoid unnecessary tracking is to use only open, standardized middleware, so to say, or brokers. They don't know what you are doing as an application. They can at most log with whom you communicate. But if you use end-to-end encryption, that's all. They cannot, since they don't know your use case, they cannot access the data, they cannot do more. So you have to weigh the benefits against the vulnerabilities, but it's a very good solution to protect private information and confidential information, perhaps not criminal or terrorist information. Now, but it's not sufficient to protect or exact responsibility in a legal sense. It's sufficient to do a selective response. If someone requests information from you, you can select to return that information or not. But when we talk about money, we talk about contracts, we talk about future events, we talk about accountability. Pseudonym is not sufficient. We need to have a legal identity in order to exact accountability and responsibility. So when we talk about economy, we talk about smart contracts, we need a way to model legal identities. And that's why this is included in the IoT harmonization effort. So in the IoT harmonization effort, any user with access to the network can apply, not be granted, but apply for a legal identity to be registered with the network identity. And with a legal identity, I mean a collection of information about that person, which changes from country to country. In Sweden, we might have the personal number or name. That might be sufficient. But in other countries, you don't have a personal number. You have a name, you have an address, you have a working place, you have a birthplace, and so on. It differs, but it's a collection of information. So you combine a very strong private cryptographic key with the legal identity and the network identity, and you send this in an application online, obviously, it's in the network, to the broker. Now, the broker, the operator here, becomes what we call a trust provider. The broker introduces trust into the network. It acts as a notary. And so you as a person have a personal relationship with the broker where you have your account. You have sent the application, and the trust provider authenticates your information. It can be online, for instance, if there is an online proper authentication mechanism, like the bank identity here in Sweden, or it might be a manual ocular authentication once, where you show the broker your identity card, and they verify that you are you. And once you're identified, your public cryptographic key is registered together with the network identity and the legal identity. And the broker also makes sure the person signs the terms of and conditions. So legal responsibility can be delegated to the person. So if the person signs something, that person also becomes legally responsible. In some countries this is automatic, in other countries it's not. So the operator has to take that into consideration. Now, remember the broker operator here. Brokers are federated. So this means that anyone, any company, any organization, any private person, any government agency can become a trust provider. The amount of trust that you introduce to the system is proportional to the amount of trust you have as an organization. So a bank would have more trust than an anonymous small business, for instance. But it might depend. Anyone can do it. This is the nice thing with open standards. No single entity controls this. Now, who has access to this legal identity? Because it's very sensitive personal information. So you have different technologies obviously available. But in the one proposed by IoT harmonization, it protects the privacy of each user by limiting access to the legal identity to anyone who is a part in a smart contract where the person has signed, or the trust provider itself. So obviously the operator of the broker has access to the legal identities that are attested, verified. But they are not openly accessible. So only people who are parts in a smart contract where the person has signed have access to the actual legal identity. So this is a way to protect this very sensitive information. Yes, let's have a question here. I just figure out how this works.
Yeah, well, I was thinking that when I looked at your fine list of all the economic benefits open standards create, I was starting to think, okay, where in the system is the choke point where someone can establish a monopoly and sort of take all the profit? Because that happens almost in every system.
Yes.
And I just realized that trust provider is the choke point.
A trust provider, if there is only one trust provider.
Because trust providers have different trust, as you just said.
Yes.
So the trust provider with the most trust will become the monopoly owner of all transactions.
But monopoly means one.
No,
So for instance, if we take banks.
no, it's a practical monopoly. And it's the same as in property ownership.
Yes.
If you have the in Stockholm, if you own the properties at the middle of the city, you will sort of gain most of the profits that is created in the city.
So let's take a practical example, because this is has been also discussed. But I agree that this concern is a valid concern. Now, so we haven't yet defined what the value of the currency that we will discuss is. And so the trust provider who provides trust into the network, there are different types of trust, different types of values, different type of operators possible. So let's take a sport, a football club, private football club. They could be a trust provider for their members. They can have membership fees. They can do transactions of things in the open fairs with this new type of value. They can automate their things with their own internal currency. That's not in competition with, say, your salary. If you're talking about larger amounts, who would you trust your salary with, unless you have it in your pocket? If you have larger enterprises that do international business with a lot of money, who would they trust, and so on and so forth. And this gives room, since this is open, any broker can compete with anyone else for their trust of their users. And there could be different offerings based on what type of customer they have. So it's not a monopoly in that sense that only one type of organization can be a trust provider. So anyone who has an idea to provide trust for some use can be a trust provider. Now, the question becomes more interesting if we talk federation. Because if we only see it as a local broker in a microcosm, it's one thing. But when we start to interact, if, for instance, I have a broker and you have a broker, and we have users that trust us, but none of my users trust you and none of your users trust me, how can they do business between each other? And so if we can trust each other, we can make our brokers trust each other, and we can have our users exchange value between themselves. But then it's a matter of who can we as a broker trust? And that depends then. So if you have sporting organizations, they might trust others they know. If you have banks, they might trust others they know. If you have a company or a large company, they might trust. You see my point? So it's a valid.
I see the point, but the thing is, as long as it's possible for a trust provider to charge for the help of identifying and generating trust, they will sort of tend to grab as much profit they can from every transaction as possible. And that's the problem, I think. If you can create a system of trust providers where it's totally forbidden for trust providers to actually charge anything.
So this is the nice thing about this.
For this.
So this is the nice thing. This is an open standard.
Yeah.
So anyone with an idea on how to do a trust provider better than others, they can do so.
Yeah.
And if a trust provider starts charging too much, then someone else can offer another solution that charges less.
Probably not, because it's the same argument as saying that anyone can compete with Google by starting a
yes, as long as there is one player. That's why you have antitrust law. So the point here is to make sure, obviously.
But antitrust laws doesn't work the way that they tear up things that is too big because they naturally became that big. They prevent things to merge when you have two.
They can also divide things.
Yeah, but not. Google isn't dividable. They could divide things in the US.
Let's see. They have employed some quite good antitrust lawyers recently, I heard. So,
but they might split it in different business divisions and force it.
But still, there is nothing in the standard that prohibits you from creating a completely free trust provider. So if you manage to gain someone else's trust, they will be able to do business with anyone where this trust extends. So then it's up to you to build a reputation. Now, a company that extorts their customers will lose their trust, I believe, personally. And so I think there is a regulatory feedback mechanism into this trust mechanism that will help all participants to gain as an optimized, as good as possible trust model in the network. But as you say, in the short term, there might be oscillations, but in the long term, these will cancel each other out. We'll have to see. Anyone else with it? Or you had a second question? Well, let's discuss this further. Think about this in the back of your heads, and then we'll discuss this further. So, legal identities. Now, that's only the first step. We need legal identities in order to do smart contracts. Smart contracts wouldn't be contracts if we couldn't connect them in some way or exact responsibility. And so IoT harmonization defines smart contracts. In a sense, it provides a container format, first of all, that contains all the information available about the contract. It provides the broker with a repository of smart contracts. It's federated. There is not one repository, so each broker can have a set of contracts that it has stored. Any user with a legal identity can upload a contract. Any legal identity can sign it. So a signature here, we'll talk more about that, is a cryptographical signature using the private key of the contents of the contract. As we said, a contract has parts. You talk about parts of a contract. Parts of a contract are those individuals that have signed the contract, or those companies that have signed the contract. So parts of a contract also have access to the contract, can read it. The content of a contract is not, it is machine readable. So the content has semantic value. The basis here is to act for automation, so it must be machine readable. And the trust provider makes sure that legal responsibility is delegated to the individual. So you can rely on this contract. In some countries, like Sweden, this is more or less automatic, but in other countries you need to make sure each participant who registers a legal identity also signs that they will take responsibility for any smart contracts that they sign with this legal identity. So this is called the terms and conditions. Now this container format, obviously a contract has an identity. In information technology we love identities. So the contract can be referenced in this federated network. So as you know, any broker can have any number of contracts. We need an identity mechanism to identify contracts globally. It has this legal content which is based on XML and specified by namespaces. Talk more about that. It has obviously timestamps. It has options. Visibility, do we want this contract to be public, or is it a private contract between the parts? And it has a set of signatures. Now, the signatures contain the identity of the legal identity. The legal identity also has a federated identity. It has the cryptographic signature of the entire contents and the timestamp. And the trust provider acts as an electronic notary. So in many countries, a contract is not valid unless it's signed and validated and attested in a public notary. Now the trust provider becomes an electronic notary. So the trust provider also has a set of public and private keys. And so they attest to the validity of the contract, they attest to the signatures actually being signed correctly, and it signs the document also. And so anyone that downloads the smart contract not only can understand what it contains, it's machine readable, it can also find out the legal identities, it can validate the signatures, because you only need the public key, anyone can have access to the public key. They can validate that they signed a contract as it is stated. Anyone trying to change any character of the contract, that will be shown by the signatures becoming invalid. And we know that the signatures of the contract are actually made and registered with the broker, because the broker notary signature is also valid. So we know it's not forged outside of the system. So it's very securely signed. We discussed in the cryptography lecture last time. This is why also we introduced cryptography, to understand this type of cryptographic signatures with the elliptic curve. So they have a very strong elliptic curve signature on the contracts, and the interesting part here obviously is that if you compare to other smart contract solutions, is that you actually have a notary function. The trust provider, which is measured on how trustworthy they are, also attest to the not only contents, not only signature, but also the state. So a contract has a state which shows in the current state, if it's valid or not, or others. Which makes these smart contracts very, very reliable from a legal point of view. Now, I mentioned the contents is defined in XML. Now, this has some very interesting properties. One thing, obviously, is that it's machine readable and it's transportable over XMPP. So it ties nicely into the XMPP infrastructure. But since semantic meaning in XMPP is defined by namespace, anyone with a domain can create any contract. So you, as a domain owner, can create your own domains. A standardization organization can create standard documents with standard semantic meaning. There is no limit to the amount of types of contracts we can define, and since they're defined by namespace and controlled by domain name, they won't collide. Now, so this makes it flexible and extensible. But we can also attach XML schemas. So we have methods, automatic methods, to validate that the contents of a contract is actually well formed and also complete. So we can automate the entire authentication and validation of the contents of a contract. So this is obviously very desirable by a notary. Normally a notary has to manually read the contract, validate that all is legally well prepared before they attest to the signature of the parts. In using XML, we can automate the entire notary function. So to summarize, okay, there's a question before, if we can.
Quick comment.
Okay.
XML also helps in translation. You can have different languages.
Yes. So this is true. So XML you can transform between dialects, and so if you have multiple versions, of a contract or similar contracts, you can transform them. So if you have a non-disclosure agreement or a property contract or something else between different companies, you can actually automate the translation between them so you understand each other's dialect. Yeah, but it's XML doesn't help in the translation of human-readable language, but in machine-readable language it helps. So this is true. So, to summarize, we have a model with federated trust. Instead of building smart contracts on distrust, as other technologies do, the IoT harmonization build smart contracts on trust. And the trust is federated, so there is not a single player who can own the infrastructure. The trust provider becomes a notary, automatic notary, adding with its trust value to the smart contract. And obviously the federation also distributes risks and helps protect privacy. So since the broker can access or limit access to contracts, to legal identities, to parts, or to the operator, the notary itself, it acts as a protection of privacy instead of having the smart contracts automatically publicly available. So this is a good way to protect the privacy of private citizens. And it uses cryptographic signatures to assure the authenticity of signatures. So that's a summary. Now, what do we use smart contracts for? So smart contracts is not just a nice feature to have because it sounds cool. It has actually a meaning in IoT harmonization. There is actually use cases built around this. So to understand this, let's talk a bit about zero configuration networking. We've discussed how to automate various parts of the installation and configuration of components in a smart network, a smart city being one example. And so this automation is divided into 4 steps. And the goal here is in each step to offload the responsibility from one part. So in the first step, we discuss ownership. We discussed this when we talked about thing registers and how it offloads the problem of matching a thing with its owner. The manufacturer doesn't have to know that at production time. So it offloads some of the responsibilities of the manufacturer. Then we have, in the second step, discovery, where smart services, smart provider, or anyone can find devices. So this helps in configuration. We can create services, we can create things that configure themselves automatically, and so this offloads responsibility of the party that configures, if that's the manufacturer or operator. In the third step, we add decision support. So when things need to make new decisions, how are they supposed to behave? And so decision support offloads this decision making. It's not no longer a requirement for operators to do access control, for instance, as it is in many solutions. And the fourth step is okay, now we offloaded to the owner. How can we offload the work from the owner? So if the owner has a million devices, they don't want to go answering questions all the time. So we need a way to automate provisioning from the owner, and this is where smart contracts come in. So this pointer doesn't work on the television, so let's try this virtual laser pointer here. So let's discuss a bit technically how these 4 steps are solved in IoT harmonization. So the first step, matching ownership. We discussed this when we discussed registries or bulletin boards. So we introduce between a thing and its owner, we introduce a concept called a registry, which acts as a bulletin board where things register themselves. So a thing registers their conceptual identity to the registry and a random key, and the thing registry remembers the address of the thing. Then the thing, in some out-of-band way, transform the conceptual identity to the owner, perhaps through a QR code like this. So this QR code contains the conceptual identity of the thing. The first individual or person or entity that learns the conceptual identity of a thing exactly, including the key, is considered to be the owner. And so the owner can claim a device by sending the same conceptual identity. If they match, the owner is informed about the address of the thing, and the thing is informed about the address of the owner. And also if the owner wishes for the thing to be public or private. So in this step, now the thing knows who to ask if something happens. Now, the second step, to automate or to offload operator. If something happens, something new happens. We have a thing, we have an owner, they're connected with this registry, and there enters a controller. It searches for new devices and finds a set of devices and chooses to do something. It performs an action on the thing here. Now the thing doesn't know the controller, what to do. So the thing obviously can ask the owner, and the owner can respond. Now, the controller found the thing and could connect to the thing and perform actions on it without the owner without the operator being involved. So here we have offloaded responsibility from the operator who provides the infrastructure to the owner. This is the second step. In some solutions available today that are very common, this access has to be configured often by the operator itself, this access control, or the manufacturer. In this second step, it's offloaded to the owner. It's still not sufficient, because obviously now the owner has to respond to a lot of questions. So the third step here is to introduce a provisioning server, which offloads some of the work that the owner has to do. So we have the thing, we have the owner, they're connected here, and the controller does something. Now, if the thing already knows the response to the question, it can do the thing without asking anyone, obviously. Now, if it's a new thing that happens, it asks the provisioning server instead of the owner. Now, the provisioning server is much more capable of determining what is supposed to be done or not. And so if it can respond, it does so. If it doesn't know, it always says no, because we want to implement an infrastructure that uses data protection by design and by default. That means that if we don't know, it's not permitted. But the provisioning server can at the same time send a slow message to the owner saying, something new has happened to your things. What do you want to do? And allow for a broader response, because the provisioning server now wants to help the owner. It doesn't have only to consider the thing. So the owner can respond in a much more broader sense, and in its own time. The owner here being a human, it can respond tomorrow, in the next month, whenever. It doesn't have to respond immediately to the thing. But when it responds, the provisioning server can learn from this response and ask the thing to update. Now, the next time something happens, the provisioning server will give the thing a new response. So here we have offloaded some of the work from the owner. I would say a lot of the work, because here now the owner is only molested when we have big changes, and can respond in its own time. Doesn't have to respond immediately. And this is where smart contracts enter, the fourth step. How do we automate even the last provisioning? And this is the point of the entire talk today. So we have a thing, and we have an owner. They're both connected to the provisioning server. But now instead, the owner uploads a contract proactively. The owner doesn't have to react. It uploads a contract where the contract stipulates the conditions are, what the conditions are for accessing the device. And it may include a lot of things, not only who has access, but also on what conditions, for instance, if there is a cost involved. Now, if a controller asks something to the thing and the thing doesn't know how to answer, it goes, the thing asks the provisioning server. Now, the provisioning server can has a much broader base to respond to. But if it cannot respond, it sends the contract to the controller this time, not the owner. So if a completely new controller comes in, it hasn't signed the contract. The controller receives a contract saying, okay, if you want to access this device, these are the conditions. Do you want to sign? And as soon as the controller signs, the provisioning server learns the owner hasn't been involved at all. So in this fourth step, we have automated almost everything. The only thing that is not automated is a legal signature, and that cannot be automated because it involves economic promise that the person has to. If we automate that, then we have turned the person into a slave. So we don't want that. But the controller wants access and has to choose if it's worth it or not. So here we enter the purpose of the talk, the economic feedback. So we have a smart contract. We have a language for smart contracts for automatic provisioning, and it includes definition of data fields, operations like readout or control. It contains information about how often, so you might be limited to a certain number of requests, for instance, per day or per week or per month. It includes fees and tariffs, so you can have different fees for accessing the device. You can have other fees for readout, control. You can have monthly or weekly or daily fees. There's a lot of things you can specify. And as things happen, as controllers interact with devices, the devices report to the provisioning server what has happened, and the broker accumulates according to the smart contract's usage and generates payment instructions. Now, this is where IoT harmonization ends. So it has realized an infrastructure where all these things can be automated and managed securely. It provides a mechanism to have legally binding contracts. It measures usage and generates billing information, you could say, or payment instructions. These are then handled out of band. So they are, sorry? Out of band means outside of the scope of the standard. So this is the last period of the standard. So the standard leaves the operator with these payment instructions. And this is where the operator stands to gain, obviously, also, because they have to attract users, so they provide this infrastructure, but they can also obviously have a business model around facilitating the economy. Now, I say that IoT harmonization ends here because on this and within the scope of this project that Internet Stiftelsen has funded, we have designed and developed a new type of electronic currency that integrates into this IoT harmonization. And this new type of currency is based on this trust provider backing value of this currency. So it's based on this trust. And obviously it ties into IoT harmonization in the sense that these payment instructions are automatically converted into automatic transactions using this new type of currency. And it's federated, as we've discussed. It's backed by real value, so it's not a fictitious value. So there is real value, and it has several very nice, interesting properties, this new currency. So it not only supports online transactions, but also offline transactions. And this is very interesting. So you don't actually need a physical connection in order to be able to do transactions with this currency. And its protection against theft is we say it's environmental friendly because it doesn't require immense computing power to mine, and it's also application agnostic. You can use an email program to mail a transaction if you want to. So it's not bound to any type of application or such. And it can also be used for transparency. It protects privacy, but also it has other nice aspects that will be presented in another talk. So I would like to round this talk off here. We have had a long series of talks, lectures. This is the sixth lecture. The seventh lecture has a tentative date on the December 12th, where this new type of currency will be properly launched. It's called e-dollar, and for those that are not familiar with the dollar, I recommend you look it up in Wikipedia, not using Google. We also have a sequence of labs where we concluded also the sixth lab yesterday. The next lab has no date set yet, but there we will elaborate using smart contracts and see how that works. Many of the things mentioned here is mentioned in the book, in my book, but obviously not the most recent developments. So for more information on that, I refer you to the lecture or presentation the 12th of December. So any questions remaining that are festering in you, if you don't agree or have worries or anything, please go ahead while we're still recording. If you don't want to end up, we can talk later afterwards also. For the viewer, I can say they're very skeptical. No question? Everything is clear as mud? What can go wrong? Yeah. Well, I have some questions here prepared. What could go wrong? So we discussed that. So obviously, with any new type of paradigm, any new type of invention, there's no way to properly assess every outcome. So what we have done is we've prepared this with all the problems and vulnerabilities that we are aware of in order to make this as free and open and secure as possible, obviously. But technology and development never changes, and this will not be the last step either. So that's the what could go wrong. Any other? Counting, yeah.
Counting. Taxes.
Yeah.
How do you measure wealth?
Yeah. So obviously, if you have, if you're a trust provider that manages a proper payment service, as this might be defined as, there are laws and regulations defined by the finance ministry of each country. Now, this new currency provides tools that helps the provider with transparency in that regard, and to help also any organization or any company that want to avoid using illicit monies. So in that regard, but more on that on the next lecture. Up to this point, where IoT harmonization leaves off, finance ministries are not involved anymore yet. So the values that could be defined in this contract might be, it can be, I mean, number of buns or a cup of coffee. Or it doesn't have to be within the scope of finance ministries. You had a question. You had to take the microphone also, in case you had a question. No? Are we done? Okay, so then I want to thank you for attending. Thank you also for viewing online. And if you have any questions, don't hesitate to contact me. Okay, thank you.